Hello everyone, welcome once again to our channel. In this video we are going to do exercise 2.2. Okay, so let's start with the first one. Okay, so as you can see, the first question is you have to prove the following, where we have 3 sine inverse x is equal to sine inverse of 3x minus 4x cube. Okay, now whenever you see this kind of questions, you have to apply the formula which you have already studied in your class 11th trigonometric functions. Okay, so you have to apply those formula. Now looking at this 3x minus 4x cube, so you have to recall the formula of this. So if you put, instead of x, if you put sine theta, it becomes 3 sine theta minus 4 sine cube theta. Okay, so that is actually the formula of sine 3 theta. So like this you have to take the formula. Now in this we will prove this by LHS is equal to RHS, because you have to prove that LHS is equal to RHS. So we will first consider our LHS. It is 3 sine inverse x. Okay, what about RHS? Your RHS is sine inverse 3x minus 4x cube. So as you can see, in LHS there is nothing to prove as such, it is 3 sine inverse x, but in RHS we are going to apply the formula. So in this case, let us consider, let x is equal to sine theta. Okay, so when you consider x is equal to sine theta, that means you have sine inverse x is equal to theta. Okay, now looking at this, your RHS value you can write, therefore your RHS is, so how you can write this, the value is sine inverse. Now in place of x you can write sine theta. So it is 3 sine theta minus 4 sine cube theta. Okay. Now what is this 3 sine theta minus 4 sine cube theta? It is nothing but the formula of sine 3 theta. Okay. So this you have already studied, that if you have sine inverse and sine, so this get cancelled. You can remove this because they are inverse of each other. So this answer is 3 theta. 3 theta means theta is what we have taken theta, it is sine inverse. So it is sine inverse x. Okay. So as you can see, this value which is in RHS is same as the value which is in LHS. Okay. So therefore our LHS is equal to RHS. Okay. So hence it is proved. So like this we are going to do the next one. Let's see the next one. Okay, now let's see the second one. Okay, now same way as we have done the first one, you have to consider your LHS, which is equal to 3 cos inverse x. Okay, now RHS is cos inverse 4x cube minus 3x. So as we can do nothing in LHS, so we have to just simplify our RHS. So again the same thing as we have considered in the first one, you have to consider let x is equal to cos theta. Now because in this case you have 4x cube minus 3x. Okay, so in these type of question, the hint is you have to bring your term which is inside the bracket in such a way that you should get the inverse of this. Like here you have cos inverse, so you should get cos in this bracket so that you can cancel out the terms. Like in the first one we have here we have sine inverse, so we brought sine 3 theta in the bracket. Okay, so that this sine inverse and sine get cancelled. Same way you have to look for this. Okay, so if you consider x is equal to cos theta, you have cos inverse x is equal to theta. So how you can write your RHS now? So it is cos inverse 4 cos cube theta minus 3 cos theta. So this is nothing but cos inverse. Now what about this? This is cos 3 theta. Okay, so again this cos inverse and cos get cancelled, so you have the term 3 theta. But again that theta, the value of theta is nothing but cos inverse x. So we can write this as 3 cos inverse x. So in RHS we got 3 cos inverse x. Same way in LHS this was 3 cos inverse x. So therefore our LHS is same as RHS. Okay, so hence it is verified, therefore it is proved. So like this you have to do these type of questions. So for this you have to remember the formula, the trigonometric formula that you have already studied. Okay, now let's start with the third one, where you have the function is tan inverse under root of 1 plus x square minus 1 upon x, and this x should not be equal to 0. What we have to do, we have to write the following functions in the simplest form. Okay, that means you have to simplify it, okay, till we get the simplest form. So let's do the third one. Okay, so before starting this type of question, just give a few seconds to just look at the question and try to find out which trigonometric function should be put as x. Okay, so we have 1 plus x, and at the end we should get in the bracket, now this is the bracket term, so in the bracket we should get tan, so that this tan inverse and tan get cancelled. Okay, so that we can remove the terms. So you have 1 plus x square. So now you have the choices, like you can put, now 1 plus x square is for, like if you do it you have to do, just find your x. Okay, so it is 1 plus x square. First look at this under root term, it is 1 plus x square. So just recall your identities, trigonometric identities. What all identities we have? So we have sine square theta plus cos square theta is equal to 1. Then you have sec square theta minus tan square theta is equal to 1. And the last one is cosec square theta minus, it is cot square theta is equal to 1. Okay, so we cannot apply the first one. That means we cannot put sine or cos it as x, because if you take cos square to this side, it is 1 minus. If you take sine square to this side, it is 1 minus, but we want 1 plus. Okay, now if you put these from the second one, so in the second identity you have sec square theta minus tan square theta. That means from this second one you can write that sec square theta is equal to 1 plus tan square theta. It's okay, so it will work because we have tan in our question, so we will not consider the third one. Okay, so just put this, so you will get 1 plus, now we are putting x as tan theta, so it is tan square theta. Correct, so tan square theta will give you sec square theta in under root, but when you take out from this, it is sec theta. So like this you will get sec theta minus 1, and in the denominator you will get the term, because we have denominator mein kya hai, x, so that means it will tan x. Now we can simplify it further. We will convert this into sine and cos, and then we have to simplify it further. Okay, so like this, first you have to consider your x by looking at the question. Okay, so what we are using here, so first of all let's take, you can write, let, we are putting x is equal to tan theta. So here tan inverse theta, no, tan inverse x is equal to theta. Okay, so this is our first step. Now let's take the question. So you have tan inverse under root 1 plus x square minus 1. I'm sorry, this is only this under root, not here, upon x. Okay, so this is equal to, now you have tan inverse under root 1 plus tan square theta minus 1 upon tan theta. So what you can do, you can write this as tan inverse, now 1 plus tan square theta, as I said, it is sec square theta minus 1 upon tan theta. Okay, so what we have used, so we have used the trigonometric identity, because we know that sec square theta is equal to 1 plus tan square theta. Okay, so for this you should remember all the trigonometric formulae from your class 11th. Now when you take out this sec theta out of the under root sec square theta, it is sec theta minus 1 upon tan theta. Okay, now what you can do, you have to just convert the sec and tan into sine and cos. Okay, so it is 1 upon cos theta minus 1. Whenever you get this sec and sec theta, tan theta, cosec theta or cot theta, and if you are not able to find any formula for this, so you have to just convert the terms into sine and cos. That's the simplest way we can do. So it is sine theta upon cos theta. So what about this? This is equal to tan inverse, just take the LCM in the numerator, so it is 1 minus cos theta upon cos theta, the whole divided by, in the denominator you have sine theta upon cos theta. I hope you all getting this. So this cos theta and cos theta from the denominator get cancelled, so we will get the term as tan inverse, okay, 1 minus cos theta upon sine theta. So this is again one milestone that you have to reach over here till this point. Now again we have to apply some formula, okay, at this step. Okay, you cannot solve it further like this, so you have to apply some formula. And mostly in the case of tan inverse of this kind of function, whenever you see this function in the bracket like sine theta 1 minus cos theta, 1 plus cos theta, or 1 minus sine theta, like this if you get, so you have to convert it like this, what we are going to do just now. Okay, so let's look at the next step. Okay, now we have reached the step tan inverse in bracket 1 minus cos theta upon sin theta. अब हमें क्या करना है? We are going to do like we have to convert this 1 into sin and cos. This cos again we have to apply the formula. Sin के लिए भी again we have to apply the formula. Okay. Now as you know that if you have sin theta, sin 2 theta, what's the formula of sin 2 theta? You know that it is 2 sin theta cos theta. ठीक है, साइन के लिए फॉर्मूला क्या है? यू हैव साइन टू साइन थीटा कॉस थीटा, बट इंस्टेड ऑफ दिस 2 थीटा इफ़ यू हैव साइन थीटा, ओके, बिकॉज हमारे पास यहाँ पर क्या है, साइन थीटा है. ठीक है, सो साइन थीटा के लिए व्हाट यू कैन डू, साइन थीटा इज, जब यहाँ पे थीटा हो जाएगा सो दिस विल बिकम थीटा बाई 2. ये इसका हाफ है, यहाँ पे 2 थीटा है, यहाँ पे थीटा है, यहाँ पे थीटा है. इफ इट दिस बिकम्स थीटा, सो दिस इन द फॉर्मूला इट बिकम्स थीटा बाई 2. Same way, when you apply the formula of sine square theta, if you use this identity, sine square theta plus cos square theta is equal to 1. Okay, so in that case, now we want everything in theta by 2. So this is sine square theta by 2 plus cos square theta by 2 is equal to 1. Okay, Okay, so in this term 1 minus cos theta upon sin theta. So for sin theta we are going to use a sin theta formula, which is this. Sin theta is 2 sin theta by 2 cos theta by 2. Okay, and for 1 है ना, यहाँ पे 1 है ना, for 1 we are going to use the identity, which is sin square theta plus cos square theta is equal to 1. And for cos theta you have to apply the cos 2 theta formula. So do you remember the cos 2 theta formula? You have cos 2 theta. The formula for this is cos square theta minus sin square theta. So when you have cos theta, this angle become theta by 2. So instead of cos theta, we are going to write this formula. So we will put all these formulae in the term which is tan inverse. So you have, for 1 we will write sin square theta by 2 plus cos square theta by 2. For minus cos theta, so we will apply this formula. So this is minus cos theta by 2, and this minus minus, this becomes plus. So it is plus sin square theta, sin cos square theta, sin square theta by 2. In the denominator we have sin theta, so we will write 2 sin theta by 2 into cos theta by 2. So as you can see, this cos square theta by 2 minus cos square theta by 2, this get cancelled. Okay, let's see question number 4. We have tan inverse under root of 1 minus cos x upon 1 plus cos x. Okay, now one thing again we have to remember that in order to solve this, first we have to make this bracket part. Okay, we have to solve this bracket part and we have to make this in tan something. Okay, so यहाँ पे tan inverse है, so ये bracket में क्या आना चाहिए, tan of something. तो इस तरह से इसको convert करना है. Now because this is in cos, so first we will try to write this in the form of sin and cos. So how we are going to write this 1 and cos. So for 1 you have the identity. As we know that sin square theta plus cos square theta is equal to 1. So we can write this 1 as sin square x by 2 plus cos square x by 2. ठीक है. Same way for cos x, because we know that cos 2 theta is equal to cos square theta minus sin square theta. So cos x becomes cos square x by 2 minus sin square x by 2. So we are going to use these two in this term. So we have tan inverse under root. So for 1 we will write sin square x by 2 plus cos square x by 2 minus, for cos we will write cos square x by 2 and then minus, and this minus minus minus, this become plus sin square x by 2. Same way in the denominator it is sin square x by 2 plus cos square x by 2 plus cos square x by 2 minus sin square x by 2. Okay, so just complete this bracket. So you have, this is equal to tan inverse. So as you can see, this cos square and cos square get cancelled, sin square and sin square from the denominator, this get cancelled. So we have under root sin square x by 2 plus sin square x by 2. In the denominator we are having cos square x by 2 plus cos square x by 2. So how you can simplify this further? It is 2 times sin square x by 2 upon 2 times cos square x by 2. Okay, so when we solve this further, 2 get cancelled. So what is left inside the root? It is tan square x by 2. So that means this will give you tan inverse in bracket, take it out from the under root, it is tan x by 2. Okay, so our final answer is actually x by 2. So this is our answer. So this is how you have to make out from the question. If you are having tan inverse outside the bracket, so you should make the bracket term in terms of tan only.